So welcome to part 3 of electrophilic addition to alkenes. In the first two parts, we had an overview as well as the mechanism for the general carbocation process in which we do Markovnikov's rule. Now let's continue with that carbocation, but look at the possibility of rearrangement. You may have seen rearrangement when you talked about SN1 or E1 reactions, where you form carbocations in those. So starting out, if we had something like this and we added HX, the first step would be adding the hydrogen, and we would add it to the side with more hydrogens, meaning our carbocation would go here then. That is a secondary position. Remembering what a hydride shift is, I could shift a hydrogen over, and the positive charge would now be there, or I could have shifted it over this direction, and the positive charge would be there. These are both primary carbocations. Secondary is more stable than primary, so the shift will not occur in this scenario. Whereas if I were to try a different starting material here, in which I extended this, when I add that hydrogen, I would still get a secondary carbocation to begin with. But over here, we have a tertiary position. So if I were to shift this hydrogen over, I would now have a tertiary carbocation, which is more stable than secondary. So rearrangement will occur. And after I add my X minus, let's not make it too complicated with the arrow. Let's do it there. I would get this product. Now, the reason why it's important to understand the mechanism, because if you just saw this starting material right here, and we added HX, you would think, oh, Markovnikov's rule, I'm going to add hydrogen to the side with more hydrogens and X to the side with fewer hydrogens, and I would get this. But that would be incorrect because the first step forms a carbocation, and we have to pay attention to possible rearrangement. So understanding that shortcut Markovnikov's rule is a good starting point, but make sure you identify scenarios in which carbocations could rearrange, where we could have a hydride shift. And at the end of all of these videos, I will have some practice problems that we will walk through in which we have to examine all scenarios. So stick around for part 4, which is going to move into the ring formation mechanisms, which for these, we don't have to worry about rearrangement. And also, it's a way to do a Markovnikov addition of water, again, without that rearrangement.